Welcome to the world of science. In today's episode, we are going to be talking about trouble in the marsh with oil. Follow me and we'll talk more about this. Louisiana, home of the bayou. Louisiana, home of the bayou. But not all was well in the bayou on April 20th, 2010, when one of BP's oil platforms exploded and free-flowing oil flowed into the Gulf of Mexico off the coast of southern Louisiana and New Orleans for 87 days. And it is considered quite possibly the largest oil spill in the history of petroleum.
11 people are missing after an explosion and fire at an oil rig in the Gulf of Mexico.
Thousands of gallons continue to pour into the Gulf of Mexico.
A rate of more than 500,000 gallons a day.
Says the oil slick in the Gulf of Mexico is now the biggest environmental disaster.
It's not floating.
Now we will go to Phil Schneebly for our microcosm experiment on the Deepwater Horizon oil spill.
My name is Dr. Phil Schneebly, and here I am at the site of the Deepwater Horizon spill. We've taken a sample of water from the bottom of the spill, and you can see here the extensive discoloration that the oil has caused upon the fish. Yes, these red snapper are not red, not gold, but a darkish grey, because the oil is black. And we have noticed some deleterious effects that this has had on the fish, including, among them, death.
So what we want to know in this experiment is if under conditions where nutrients are not limiting, if microbes will be able to bioremediate or eat the oil faster than they would under normal conditions.
I'm oil, I'm oil, I'm oil, I'm oil, I'm oil. I'm oil, I'm oil, I'm
And also under these new conditions, will the salt marsh be stressed out to the point where the eating of the oil is outweighed by the costs of the damage to the salt marsh?
Our theory is that if we could somehow find a way to get rid of these 210 million gallons, or that is approximately 840 litres to those in science, we might actually find some way to get rid of it in a microcosm. But to create a microcosm, we need an expert, and as far as I'm concerned, no such expert exists.
Hello, my name is Dr. Ching Chong, and I am a microcosm expert. And from one of my understandings of our situation, we believe that we're gonna try an experiment. So I'm a microcosm expert, and we believe we have a hypothesis that in believing that because of the salt marshes there's a deficiency in oxygen, and that with nitrogen being the next best we believe that with nitrogen being the next best electron acceptor, that it is the limiting nutrients in these microorganisms, and that if we are able to take away that limiting factor, that these microbes are going to be able to eat these oils a lot faster and to be able to clean up the environment better. So with that, we are going to set up these experiments that involves these plots where we're going to test out the we're going to have these plots that are going to simulate the environment and try out different combinations of using nitrogen as we're trying to create these micro environments that has the same salinity and nutrients as these marshes. Hello there again. It has been 2 weeks and it has proven successful that it seems that points that the nitrogen is the limiting factor of these bacteria, and that has worked sufficiently well enough in these controlled environments that it should work also out in the field.
In order to test their hypothesis, as developed from the microcosm experiments, that nitrogen and urea will in fact stimulate oil degradation in the Louisiana swamp marsh, a systematic test was set up in Terrebonne Parish, which is very southern Louisiana in a typical salt marsh. Exactly replicated how it would be where the oil was. What they did is they did 10 test plots, and inside each test plot were a section that was blocked off for oil and time-released urea in hopes that the urea would function as a way to instigate oil degradation by using urea as a terminal electron acceptor in these anoxygenic conditions. They had a control where they did absolutely nothing to it. They put no oil or anything like that into it. They had another one that had oil and nitrogen in hopes that the nitrogen could instigate the oil degradation, except this nitrogen is not time released. They simply added it and let it be. And the very last one was just straight oil and no nitrogen. And inside these test plots, there are 36 little...
Hi.
How's it going?
I'm good. I'm
good?
gonna lock this door.
Go
when
for
you
it.
guys are done, can you turn off the lights?
Yep, gotcha.
Thanks so much.
Keep going.
Check.
Just keep going.
Keep going.
Keep going.
Okay. And this one, should lock us in here? In order to randomize their samples so that they can get a actual count of how much nitrogen and how much oil was used, they randomized the samples. Inside of each box there are 36 smaller boxes in which they use to put it to a computer generator and to be able to pick one of the 36 boxes per each type of sample, so that they were able to find out what kind of results that they were able to get. Finally, after 180 days, the soil and sediment samples surrounding our test plots were taken to the lab and analyzed for hydrocarbons and alkanes that are found inside the Louisiana crude oil to see how much was left inside, whether it was more or less than other ones due to the addition of nitrogen and urea.
I thought it would work. It seems that nitrogen is not a limiting factor at all. Maybe oxygen is the limiting factor. The terminal electron acceptor. It's just all of our work for nothing. For nothing.
The Deeper Water Horizon spill has cost an estimate of $4.6 billion in economic loss to Louisiana and has single-handedly crippled the local fish industry. Louisiana's salt marshes are not as nitrogen and urea deficient as believed. Nitrogen is not statistically significant enough to be considered to implement in the marsh as a means of bioremediation. As a means of bioremediation. Another method to test would be a system to further oxygenate the waters to make microbes more efficient in eating oil. To this day, traces of oil still remain in the back portions of the salt marsh. It has been estimated that they will remain for the next decade.
Thank you for joining us. It's been an adventure. I can't say which was the most dangerous part, but we'll leave that to you to decide. Next time on World of Science, we're going to be talking about another black liquid that rules the world, Diet Coke. 5 cans a day? Too much?